Hi, I'm Bryn,
I'm Ria.
Joseph.
I'm Moses.
and we looked at data from the 2020 US general election. Our research question was, is it possible to predict turnout for an election? What are some of the significant predictors? In terms of data collection, we got all of our data. It was public data online from a compilation of 5 sources. Our data summary was we had 5 explanatory variables and 1 response variable. The first one was felons, which is the number of felons ineligible to vote in each of the 50 states. Second one was POP, which is population and just the population by state. The next one was RB, which was our only qualitative variable, and that stood for red or blue, and that was determined by party affiliation after the 2020 general election. The next one is homeless, which was the rate of homelessness, and that was calculated by the number of homeless people per 10,000. So we were able to compare it between all of the states. Lastly, for explanatory variables, we had median state income, which, as it says, was the median income per state. Our one response variable was per VEP, which is the same thing as voter turnout, but to be a little more specific, was the percentage of people eligible to vote that actually did vote. So people that went to the polls on election day. Rationale for looking at a data set like this is that voting is really important, and we wanted to look at some demographics that may traditionally be left out of your typical voter turnout analysis. Just to give some context, homeless rate could be a really important factor in something like absentee voting, as it's really hard to register without a permanent address. Party affiliation, whether state is red or blue, may indicate how many people get out and vote. Do states with fewer felons like Vermont and Maine have higher turnout? A clear benefit to looking at this data is that, as we all know, voting is a civic duty, and it is important to understand how demographics are influencing who does and does not show up to the polls on election day. Since our response variable is not binary, we will use multiple linear regression to explore our response variable per VEP voter turnout.
For our EDA, in order to determine which variables to keep and which variables to not, we decided to look into correlation matrix and correlation coefficient table, as well as stepwise regression. And after we looked into those 3 things, we decided to keep other variables except felons. So after we decided which variables to keep, we looked into the scatter plot between the percent of the EP and the other 4 quantitative variables we decided to keep. And it seems to be, there was a strong positive correlation between the state median income and then percent of the EP. For other variables, the trend was less clear. As for the percent of the EP and the party affiliation, there was a slight difference in terms of the median, but there was no other significance that was discovered when you looking at the box plot. Also, lastly, we looked at the interaction plots, and when we looked into the interactions between the variables, and we found out there was a difference in slope for homeless and the percent of EP for each state's party affiliation. So we decided there was an interaction between those 2 things.
So now starting off our 3-stage process, we have 5 betas. We have population, median state income, the rate of homelessness, our dummy variable where X is red if it's a red state and 0 otherwise. And then we have our interaction variable, which is our dummy variable times the homelessness rate. So we did the global F-test for this equation, and we got that our p-value is less than our significance level of 0.05. So we reject the null, and we concluded that this model is adequate at predicting voter turnout. And now we wanted to test, we wanted to do an individual t-test for beta 1, and we concluded that this p-value is a lot greater than the significance level of 0.05. So we concluded that population is not a significant predictor for voter turnout. So we took out population, which was beta 1. So now we're left with just median state income, the homelessness rate, the dummy variable, and the interaction. And after doing the global F-tests for this reduced model, we did notice that our adjusted R-squared value went up. So this model is better. And so for this reduced model, we then checked all the assumptions. For the mean zero assumption, none of the residual by regressor plots seem to have a linear or quadratic pattern. So this assumption is not violated. And then we looked at the constant variance graph, and we noticed that this graph did not have a fading out pattern. So this assumption was also not violated. Then looking at the normality assumption, our histogram is symmetrical and it is centered around 0. So this assumption is also not violated. And for the Durbin-Watson test, there was evidence of positive autocorrelation, but there was no evidence for negative autocorrelation. And then for our reduced model, we looked at the influential observation / outliers. To find the outliers, we looked at the Cook's D graph and the leverage graph, and we noticed that observation 50 was very different from all the other observations. So we decided to take observation 50 out, since we also looked at the DF fits and DF betas, looking at the studentized residual table, and observation 50 had a student residual greater than 3. And also the DF beta and R student values for observation 50 were abnormally large compared to all the other observations. So we decided to take observation 50 out. And after taking out observation 50, we redid the model, and our adjusted R-square value did go up. So without observation 50, our observation is better. And observation 50 was Hawaii.
So looking at the conclusion, we determined that our final and best model would include the homelessness rate, the median state income, the dummy RB, which represents whether a state was red or blue, and then the interaction between our qualitative variable dummy RB and the homelessness rate. So we took out, throughout our 3-stage model building, we took out felons and population, which is why they're not included in this final model. So after determining that this model was adequate and significant to predicting voter turnout, we fitted the regression model and got y hat equals 0.5321 minus 0.00135 times the homelessness rate plus 0.0000173 times the median state income minus 0.5878 times the dummy variable plus 0.00173 times the interaction between the dummy variable and the homelessness rate. So after this, we came up with a prediction interval, and we wanted to interpret the results specifically for Virginia. And we said that for the state of Virginia, we are 95% confident that the true percentage mean of eligible voters that voted is between 56.17% and 76.36%. So looking at the limitations and future improvements, we recognize that the model is limited to the 2020 general election, and we probably can extrapolate that to any other elections because so many variables and like the information in those can change during the 4-year period from election to election. But in the future, it would be interesting to look at education level, race, age, competitiveness, or like even the party of the governor of the state or the senators. One problem we did find was that our dummy variable, which indicated whether a state was red or blue, was for that 2020 US election. So for predicting voter turnout, it probably wouldn't be appropriate to use whether the state ended up being red or blue to predict that, since that we would find out later on election night. We did observe, again, first order positive correlation in our model. So that was the residual correlation that our model violated. And in the future, we would need to fit an autocorrelation model, but we decided to disregard that for the sake of the project. And lastly, so we did find and conclude that our model overall was adequate and good for predicting voter turnout, because although our R-squared wasn't very high at 27.37%, our adjusted R-squared, we recognized that a lot of our assumptions were met, and then we only had one outlier and influential observation, which was the state of Hawaii. So overall, I do think that this was a good model to predict voter turnout in the US 2020 general election, and it would definitely be worth it to look at all these variables again in the future election. Thank you.